Alright, so we are going to now look at page 3, 4, and 5 of your review packet. So we have the cosine of 750 that we're going to find. 750, you will notice, is actually 2 revolutions of 360 that we're going to have to take out. So I'm actually going to take out 1, and then again, I'm going to wind up at 720. So I'm actually going to be subtracting out from 750, 720, because that's 2 rotations around the circle. So I'm now looking at an angle of 30 degrees. So I'm really looking at the cosine of 30 degrees. Cosine of 30 degrees on your unit circle would put you at this portion right here, and your reference angle is 30 degrees, so the cosine of 30 degrees is going to be root 3 over 2. Okay. The next one, cosine of 22 pi over 6. You are going to want to first go ahead and translate that into degree mode, probably be a little bit easier to evaluate. So if I do that, I'm going to do 22 pi over 6 times 180 over pi. The pi's will cancel. 6 goes into 180 30 times. So you're looking at 22 times 30, and 22 times 30 is going to be 660. So as you can see, you're actually going to have to take out 1 rotation of the circle, which then will leave you, if you subtract 360, will leave you at 300. So you're really looking at all the way over here in the 4th quadrant. Okay? In the 4th quadrant, you have positive, negative, and so therefore cosine is going to still be positive in this quadrant. So therefore you're really looking at a reference angle. If you draw the reference angle here, there's your reference angle. So 360 minus 300, you're looking at the cosine of 60, which will still be positive because cosine is positive in the 4th quadrant. Cosine of 60 is going to be the same as, cosine of 60 is going to be the opposite in this case in your unit circle, which is 1/2. Alright, for the next one we are going to graph, which means we first have to identify amplitude, period, and phase shift. So, amplitude we're going to take straight from the A value, which is right now 1, so it's going to stay 1. My period is going to be 2 pi divided by B, and in this case I have no B value, so it's going to be 2 pi. My phase shift is going to be the opposite of positive pi over 2, so it's going to be negative pi over 2. And my vertical shift is going to be this portion at the end, which is 4. Now, let's go ahead and describe the transformation before we go forward with graphing and finding my 5 key points. So my transformation, since it's negative here, that's going to be a reflection over the x-axis. The plus pi over 2 is a phase shift, and that's going to phase shift left by pi over 2. The plus 4 is going to be a vertical translation 4 units up. Alright, so with that being said, your typical points that you usually use for the 1st, 2nd, 3rd, 4th, and 5th are going to be 0, pi over 2, pi, 3 pi over 2, oops, and 2 pi. Okay, so those are your typical coordinates that you're going to use for the x values. However, in this case, we have no horizontal shrink or stretch, but we do have a phase shift that we have to apply to that x value. So instead of 0, I'm actually going to start at negative pi over 2, which if you notice is my phase shift. Okay? If I evaluate this function at negative pi over 2, negative pi over 2 plus pi over 2 is 0. So I'm really looking at the cosine of 0. In my unit circle, the cosine of 0 is 1. That means it's going to be negative 1 plus 4, and negative 1 plus 4 is 3. Now you can also see this if you look at your amplitude and vertical shift. Okay? Let's go ahead and sketch those in our graph. My vertical shift is 4. So instead of drawing and starting at 0, like I typically would, I'm actually going to go up 4. 1, 2, 3, 4. And right along here is going to be where now I come back to the axis. So it's not going to really touch the axis in this case. My amplitude is 1, which means my graph is going to top out at 1 above that line and 1 below that line. Okay? So, go ahead and redraw that. So that's going to be 1 above and 1 below. Okay? So now that I have my amplitude drawn in, if I graph the point negative 2 pi over 2, here's negative pi over 2 right here. Negative pi over 2 comma 3 is going to put me right here. Now, does it make sense that in a cosine graph, it's going to start at the bottom line and go up? And in this case, it does because it's a reflection over the x-axis. Typically, a cosine graph is going to start at the top and then come around and go down. But since this is a reflection, it's actually going to look the opposite. It's going to start at the bottom and come back up and go down. So in this graph, it's going to be negative pi over 2 comma 3. Now, as I just stated, this is the way the graph is going to look. So I could go ahead now and draw in my next 5 points, because I know the graph is then going to come up here, then here, then here, and then here. Because again, that's the shape of a cosine graph. Okay? So, as you can see, it's going to come back to 0. And how do you know it's going to come back to 0? Well, you originally are going to have your second point at pi over 2, but I have to now subtract the phase shift. What's pi over 2 minus pi over 2? It is 0. And at 0, what is the value? The y value, it's 4. Same thing here. What's pi minus pi over 2? Well, what's 180 minus 90? It's just pi over 2. It's fractions. And now I'm going to go up to 5 for that one. So this is going to be pi over 2, and that's going to be 5. Now it's going to come back down. Instead of 3 pi over 2, I'm going to subtract pi over 2. 3 pi minus pi is 2 pi over 2. And how do I simplify 2 pi over 2? It's just going to be pi. And again, it's going to come pi here. And what is it? What's going to be the y value? It's going to be 4. And then finally, my last point, 2 pi minus pi over 2. And I could go ahead and give a same denominator here, which is 4 pi minus pi, which is 3 pi over 2. And that's going to be my x value. And then it's going to come back down to 3. So if you notice, 3, 4, 5, 4, 3, cosine function. Okay. Moving on to the next one. This is one that we went over in class together, so I'm just going to actually talk through this one since it already has everything written out. So the first thing that you're going to want to do is you're going to want to identify your amplitude. Again, this amplitude comes from the coefficient here, the absolute value. The period, you take 2 pi and divide it by b. b is 3, so 2 pi over 3 is your period. Your phase shift is pi over 6, and again, it's to the right. It's the opposite. And your vertical shift is 3. So all in all, your transformation is a vertical translation up 3 units. It's reflected over the x-axis from the negative. It's a vertical stretch by a factor of 2. It's a horizontal shrink by a factor of 1/3. And it's a phase shift right pi over 6. Okay? So these 5 things are actually applied to this graph. You then want to go ahead and graph the middle of the road, okay, which is kind of where your vertical shift is going to be. So you're going to graph 1, 2, 3 for your vertical shift. 1, 2, 3. And then you're going to apply your amplitude of 2, up 2 and down 2. And now you have your little road. That goes your top of your road and the bottom of your road. So your graph's going to pretty much wave between those 2 lines, coming back to this center vertical shift line. This is a sine graph, but it's a reflected sine graph, so you're reflected over the x-axis. So instead of a typical sine graph, which looks like this, it's going to be reflected. So that's why you see that it goes down first and it comes back up. Again, you're going to start at the phase shift. Your phase shift is pi over 6. Okay? Now, thinking about that logistically, in terms of where you typically have your points, 0, pi over 2, pi, 3 pi over 2, and 2 pi, okay? That's where you typically, but you're going to have to first apply the shrink and then apply the phase shift to every x value. So, the x value of pi over 2, apply the shrink, apply the phase shift. Pi, apply the shrink, apply the phase shift. 3 pi over 2. Apply the shrink, apply the phase shift. And that's how you're going to get all of your x values here by simplifying those fractions. Okay? From there, you have pi over 6. Therefore, pi over 6, and again, you can see that this sine function starts at the middle of the road, which is 3. So pi over 6, 3. Then you're going to go down to pi over 3, pi over 2, 2 pi over 3, and 5 pi over 6. So go down and back up. Okay? Alright, so for number 10, we're going to go on to the next page. A sector of a circle has a radius of 10 centimeters. So you're looking at the sector formula. Notice that they give it to you in radians, so you must use the radian formula, which is theta times r. So really, I just have to take 1.69 and multiply it by 10, which gives me 16.9 radians. Or sorry, centimeters, excuse me. It's the sector length. Okay, please make sure you give units of measure. That's important. Okay. Number 11. Sector has a again, it's a sector. Central angle is now in degrees. It gives you the radius of 7. We want to find the length of the arc. So this time we can't use pi over r. We have to use theta pi r over 180, which is the degree formula of the sector. So if I plug all that in, I get 66 pi times 7 over 180. If I simplify that, I get about 8.063 centimeters. Sector, again, of a circle, arc length of 13. So therefore now they give me the central angle of pi over 3 in radians, but they want me to find the radius this time. So in my formula, S equals theta r, I am looking for r, which means I need to plug in 13 for the sector length, pi over 3 for theta, and I'm solving for r. So to do this, I'm going to divide both sides by pi over 3, which gives me r equals 13 divided by pi over 3, which is 13 times 3 over pi, which, if I give a decimal, is about 12.41 centimeters. Okay. Moving on to angular velocity. We want the angular velocity, which is the formula W equals theta over t, or omega, little omega. Little omega equals theta over time. So in this case, remember that when I'm given revolutions, I have to convert it to radians. So 42 revolutions times 2 pi will give me 84 pi for my radians that I plug in for theta. Okay? So instead of using theta, I'm going to use 84 pi for theta, and then for my time, that's 5 minutes, so that's per minute. So 84 pi over 5 is going to be about 52.779 radians per minute. Please make sure that you give me those units. Next, again, I want angular velocity, so little omega equals theta over t. Theta in this case, I'm going to use 3.1 and multiply it by 2 pi to convert it to radians. So again, theta is going to equal 6.2 pi. So that's what I'm going to plug in for theta. So little omega equals 6.2 pi over your time, 2 seconds. If I simplify that, that's going to give me about 3.1 pi radians per second. If I want the linear velocity, I have to take linear velocity is equal to the radius times little omega. So I've already found little omega, w. I found it as 3.1 pi. So therefore I'm going to plug that in. Velocity equals, the radius is 13 inches times my little omega, 3.1 pi, and I'm going to simplify that and get an approximate value of 126.61, and that is in inches per second. Okay? Okay? Alright. Let's go ahead and move on to the final and last page. Actually, I'm going to do the last page in another video, so check for the third video.